Hello, grade fives. Today we are going to be looking at patterns and tables, and we have two learning goals that we are going to work through today and tomorrow. The first learning goal is to identify patterns in tables and represent the relationship within the tables as an algebraic expression. The second learning goal is to use this relationship, so the algebraic expression that you've identified, within the tables to solve more complex problems. Here's an example of a table. This is the number of tickets and the cost. So for one ticket, it's $8. For two tickets, it is $16. For three tickets, it's $24. How much would four tickets be? Well, I can see that this is going up by 8 each time. 8 plus 8 is 16. 16 plus 8 is 24. So 24 plus 8 is going to be 32. 32 plus 8 is going to be 40. And 40 plus 8 is going to be 48. So the pattern rule for my cost is that it is going up by 8 each time. We're representing it as an expression would be n plus 8. What's the pattern rule for the number of tickets? 1 ticket, 2, 3, 4, 5, 6 tickets. Well, that was pretty easy. It's just going up by 1 each time. Now here comes the tricky part that's new. We've already done patterns like this. We want to look at the pattern rule that relates the number of tickets, so this number, to the cost. How am I getting from 1 to 8? It's an increasing pattern, so I can multiply or add. 1 plus 7 is 8. That is true. Is 2 plus 7 16? No, so that will not work. The other option, what do I do to 1 to get 8 using multiplication? I can times by 8. Is 2 times 8 16? Yeah. Is 3 times 8 24? Why, yes it is. So my pattern rule is to multiply by 8. This is the relationship between the number of tickets I buy and the cost. You can see this because 6 times 8 is 48. How would I write this as an expression? Well, the variable would be the number of tickets purchased times by 8. So for example, if I bought 100 tickets, right? That would be the 100 would replace the n. It would be 100 times 8. So I would spend $800 on tickets. A bit absurd, but possible. I could also buy 10 tickets. If I bought 10 tickets, this n represents the number of tickets purchased. So it would be 8 times 10, and I would have spent $80 on tickets. The other way that you can find the relationship between this is always going to be multiplication or division, is I can look at what's happening here. So it's increasing by 8 each time. So that shows me that it's going to be times 8. Let's have a look at another table. This is an example of a partial recipe for cookies. It has the number of batches being made, so that means how many times essentially you are making that recipe. Sometimes you might just make one to make 12 cookies. Other times you might double the recipe or triple the recipe so that you have more cookies, especially if you're doing it for a large occasion or maybe a bigger family, or you just really like cookies. I only have included the flours and eggs so that it's not super confusing. Let's go through first and complete the chart for flour. The number of batches is pretty easy. It's just going up by 1. Our flour in batch 1 has 50 grams of flour. In batch 2, it has 100 grams of flour. In 3 batches, it would have 150 grams of flour. In 4, it would have 200 because it seems to be going up by 50 each time. So in 5, I would have 250 grams, and in 6, I would need 300 grams of flour. What's the pattern rule for the flour? I'm adding 50 grams each time, so number of batches plus 50. Pattern rule for the number of batches is plus 1, number plus 1. A pattern rule that relates the number of batches being made to the amount of flour needed. So we're looking at 1 to 50, 2 to 100, 3 to 150. It is an increasing pattern. The flour is being added by 50 each time. Because this is increasing by 50 each time, the relationship between these two is going to be times 50. 1 plus 49 would work, but it's not going to work for 2. 2 plus 49 is not 100. And I already know that this is increasing by 50 each time. So that means that this, is times 50. 1 times 50 is 50. 2 times 50 is 100. 3 times 50 is 150. So that is my rule that I am timesing by 50. How would I write that as an algebraic expression? 50n. That would help me find out if I wanted to make 10 batches of cookies because I need a lot of cookies. I would replace the n with 10 and I would have 50 instead of n. I would have 10. 50 times 10. I would need 500 grams of flour. Quite a bit of flour, but it's doable. Let's have a look at the table a bit more. What's the pattern rule for the eggs? I have 2, 4, 6, 8, 10, 12. My eggs are going up by 2 each time. What's the pattern rule for batches? We already established this. It's just plus 1. Now let's look at the pattern rule that relates the number of batches being made to the number of eggs needed. So this time I'm no longer looking at this. I'm ignoring the flour and I'm looking at what I do from 1 to get to 2, 2 to get to 4. This is going up by 2 each time. 1 times 2 is 2. 2 times 2 is 4. 3 times 4 is 6. So the pattern rule that relates the number of batches being made to the number of eggs needed is I times it by 2. Every time I make a new batch of cookies, I have to double the amount of eggs needed or times it by 2. The pattern rule that relates the number of batches being made to the number of eggs needed as an algebraic expression, just 2n. So if I wanted to make, again, 10 batches of cookies, this n gets replaced by 10, and I have 2 times 10. So I would need 2 times 10 is 20. I would need 20 eggs if I was to make 10 batches. If I was to make 100 batches, a little crazy, but certainly possible, I would replace the n with the 100. That would be easier than skip counting by 2's 100 times. Let's look at another example. So this one, you're going to create your own table. So problem is, to improve her shot in soccer, Emma practices shooting for 60 minutes each day. Make a table to show how much time she spends in a week. So here I have the number of days practiced and the time practiced each day. So in a week there's 7 days, so I have 7 days here. In 1 day, she will have practiced 60 minutes. In 2 days, she'll have done 120 minutes. In 3 days, 180 minutes. In 4 days, 240 minutes, and on and on. How many will she have practiced in 1 week? Well, I know because I've continued my table by adding 60 each time, because 60 minutes each day, to get 420 minutes. What is the relationship between the amount of time practiced and the day? If each day it's adding 60 minutes, the relationship here, is going up by 1 plus 59, but I know that 2 plus 59 is definitely not 120. The relationship is to times by 60. On the first day, I did 60 minutes. On the second day, it's 2 times 60 because I'm on the second day, 2 groups of 60. On the third day, 60 more minutes, or 3 times 60. I can use this, once I've established that it's times 60, rather than continuing my table, I could just use my algebraic expression, which is number of days practiced times by 60. So 60n. Instead of having to continue this, I could replace the n with the days practiced. So 60, I want to find out in 1 week, times 7 is 420 minutes. And that would be faster than continuing the table and repeatedly adding 60. Let's look at this a bit further. Why is this useful? Understanding the relationship allows us to solve these problems easier. So I know the relationship between the days practice and time practice is to times by 60, or 60n. I can use this to find how many minutes practiced in 2 weeks or 10 weeks. How do I do that? I know 2 weeks is 14 days. I know that this variable here, n, represents the number of days practiced. So 60n, and I can replace the n with the 14 days, so 60 times 14 is 840 minutes. That is a lot faster than continuing this table up to 16. Or you already have this, so you could double this because 14 in half is 7. How could I figure out for 10 weeks? Yes, I could continue the table, but that's not really an efficient way of finding my answer. I can use my algebraic expression or the relationship between the table. I know that the days practiced times by 60 minutes will give me how many? So 10 weeks would be 70 days. So 60 times the number of days practiced. I am going to replace the variable with 70 because I have a specific number of days. 60 times 70 is 4,200 minutes. So in 10 weeks or 70 days, Emma would have practiced for 4,200 minutes. Let's have a look at what you are going to be doing today. You're going to be doing exactly what we have just practiced. You have 2 pages. The first page is the first stuff that we did together where the table is provided and you are asked to find the pattern rule for the cost and then the relationship between the number of books and the cost and to show it as an algebraic expression. On the back side of the page, you're going to do what we just did with Emma and the amount of time practiced in soccer and create your own table, except I've sort of set the table up here for you. And in the second one, you are going to come up with the titles for yourself. Check your answers as you go, and if you are having a hard time, please come to our office hours from 10 to 11. Alternatively, if you're finding this to be too much of a challenge, you can work on option 2, which is a review of work we've already done in class.